Okay, first step, what is the first step here? Assign meshes. So mesh 1, mesh 2, mesh 3. This is the first step. And then second, okay, loop currents. I1, this is clockwise direction, I2 clockwise direction, and I3 clockwise direction, like this. Assign mesh current. Identify the meshes, first one. Okay, and assign meshes like this. And then how to deal with the current sources. How to deal with current sources, this is the concept. All of you right. The current sources in the circuit will have whatever the voltage is necessary to make the current correct. Okay, we can't use KVL around the loop because we don't know the voltage drop. Voltage drop across the voltage source we don't know. Am I right? Understood? And also in current sources we don't know the voltage drop across the current source. In current sources, so we don't know the voltage drop. Am I right or not? We don't know the voltage drop across the current source. So what we have to do? The 4 milliamps current source is set as I2 is equal to 4 minus 4 milliamps. So here I2, so I try to consider here, I2 is equal to 4 milliamps. How? Means this is a branch current. 4 milliamps is called branch. This is connected in between these two branch. Na? The 4 milliamps current is flowing like this, and I2 current, so like this. And this branch is not interlinking with the mesh 1 and mesh 3. Separate now. 1 and 3. These are separate, and this 4 milliamps current source separate. Understood? That's why the branch current, this branch current, and the mesh current are same. If it is both are same direction, then equal. I2 is equal 4 milliamps. If it is opposite direction, downward direction, opposite direction, this current direction is upward direction, and this current direction downward direction. That's why I2 is equal to minus 4 milliamps. Understood? Understood? It's clear? I2 is equal to why getting a minus 4 milliamps means because of this is a not a loop current. 4 milliamps is not a loop current, is a branch current, and also this branch current is not interlinking with another meshes. That's why this branch current and loop current both are same. That's why I2 is equal to magnitude is different. Direction based on direction, the polarity is different. I2 is equal to minus 4 milliamps. If it is a anti-clockwise direction, for example, I2 is like this means I2 is equal to 4 milliamps. You will get like this. And then the 2 milliamps current source sets a constraint on I1 and I3. 2 milliamps. So across this. So try to consider here this branch current is not equal to the loop currents. I1 not equal to 2 milliamps. I3 not equal to 2 milliamps. Understood? Understood the difference between this and this? Because of this is not interlinking with the mesh 1 and mesh 3. That's why directly we have to take I2 is equal to minus 4 milliamps. But this is different. This connected between two meshes. Connected between the two meshes. Understood? So because of that, it is interlinked with I1 and I3. That's why you will get I1 minus I3 is equal to 2 milliamps. I1 current direction, so like this, and I3 current direction, opposite direction. Understood? I1 this direction. I1 direction in this. Understood? I3 direction in this direction. But this current source direction, main current source direction, the 2 milliamps current source direction. So like this now. Understood? Then I1 in this direction, I3 in this direction. That's an I1 minus I3 is equal to this current 2 milliamps. Because of I1 is higher in magnitude, then only the current is goes like this. because of current is same direction. If I1 is higher in magnitude, then only this current is in this direction. Otherwise, opposite direction. Minus. It's clear. Understood this concept. That's why I1 minus I3 is equal to 2 milliamps. Understood. Then super mesh. This is one of the important concept. So super mesh means if any current source is connected between two meshes, is called super mesh. Understood. This is called super mesh. In between two, understood. This in this two loops I1 and I3, one source is connected. That's why this is called super mesh. The super mesh surrounds the source like this. This is called this yellow color dotted line is called super mesh. Understood this concept. This complete network is called super mesh. Is not included because of this not interlinking with this current source is not interlinking with this loop. Understood? Is only interlinking with this and this. If any resistor is connected in series, that is not a super mesh. Try to understand. If any resistor is connected here, that is not a super mesh. If any resistor, only one source is connected between these two, in between these two, I mean between these meshes, if any current source is connected like this manner, this is called super mesh. So we'll get to the super mesh equation by removing this source. By removing this source, so we will get super mesh equation. Understood concept? Three meshes, that's why we will get three equations, I1, I2, I3. That means we will get three equations. First equation, I2 is equal to minus 4 milliamps, is completed. And the second equation, I1 minus I3 is equal to 2 milliamps, second equation completed. And then third, that is called super mesh equation. So super mesh equations, how to get the super mesh equations? By removing this terminal, by removing this source. Okay, that means it is open circuited. So entering, so this is called open circuited means no current flowing in this direction. Just remove this 2 milliamp source. Okay, so this is called yellow color dotted. So it's called super mesh equation. And so minus 12, entering at minus 12. That's why minus 12 also. And then coming to here, then coming to the here in super mesh. And here I3 now. So this element, 2 kilo ohm resistor element interact with only I3. Understood? Only I3. Not with I1, not interlinking with I1 and I2. So that's why minus entering at minus terminal. That's why minus 12 plus 2k into I3. 2k into I3. Try to remember. So like this, 2k into I3. 2 kilo ohms into I3. V is equal to I into R, voltage drop across this resistor. And then coming here. So what is the current here? So in this direction, the I3 is in this direction. I2 opposite direction. That means in this direction. I2 is opposite direction. That is the opposite direction. That's why what is the resultant current here? I3 minus I2 into 1K. I3 minus I2 into 1K. So like this. Understood? The current direction, I3 is higher in magnitude, then only the current is in this direction. Otherwise, in this direction. Instead of taking here positive, so we'll take minus I2 minus I3 into 1K. But if the current directions in this direction, then only, so you have to take a positive. I3 minus I2 into 1K. The current direction is opposite across this branch. I3 is entering direction, I2 is entering like this. So then resultant current I3 minus I2 into 1K. And then here completed and here completed and then this completed. And then coming to here in this direction. You're going clockwise direction. Okay, I'm going clockwise direction. That's why. So in this direction, what is the current? I1 is entering like this. That's why I1 is higher in magnitude. Then only here plus and here minus. I1 in this direction and I2 opposite direction. That's why I1 minus I2 into 2K. I1 minus I2 into 2K is equal to 0. Then by solving these equations, so we'll get I1, I2, I3 And by substituting I1 is equal to substituting I2 is equal to minus 4 milliamps, I3 is equal, and then I1 minus I3 is equal to 2 milliamps, and by using super mesh equations. It's clear? Understood? Completed, all of you?
No, sir.
Write in matrix form and then solve I1, I2, I3. You know, simple concept. It's not required to show you. So this is the result I1, I2, I3 currents. Directly I2 is equal to minus 4 milliamps. I2 is equal to 2 milliamps. Minus 2 milliamps means here 2 milliamps. We'll get here. This only 0, I1 0, I2 2 milliamps, I3 0. Here I1, I3, I1 minus I3 is equal to 2 milliamps. I2 is equal to minus 4 milliamps. So this is from super mesh equation. It's clear? It's completed. All of you understood or not? This problem simple. It's completed. Respond. We will go to
Yes,
another
sir.
problem. Okay, next problem.
Yes, sir.
Next problem. Completed, all of you?
No, sir.
So nothing is simple. This is called one mesh, and this called one mesh, and this called another mesh. This called super mesh, and here this current direction same as these 2 amps current source. The branch current is same as this loop current, and then I1 is equal to 2 amps. This branch current is same as loop current. That's why, but opposite direction. That's why I3 is equal to minus 3 amps. And here I4 direction like this direction, same as current direction, but I2 direction opposite direction. That's why I4 minus I2 is equal to 4 amps. And then finally super mesh. So how to get the super mesh equation? So by removing this 4 amps source. No? So let us assume. So in this direction means I2 is higher in magnitude. Across you will get to positive minus. No? That's why plus positive. That's a 6 into I2 minus I1. And then coming here. So what is here 12 into I4. 12 into I4. No? 12 into I4. And then coming here 6 into. So what is the current direction? Is the downward direction I2 minus I3. 6 into I2 minus I3 is equal to 0. Then Ix is equal to, what is the current? Ix is equal to minus I4. Opposite direction. This current direction is this like this. And I4 direction like this. I4 is equal to minus Ix is equal to minus I4. Here branch current and loop current both are same because of is not interlinking with another loops. That's why. So we'll get like this. Determine the amount of power supplied by the independent voltage source. So then determine the amount of power supplied by the independent voltage source, and this applying mesh analysis method. Mesh 1. So assign meshes like this, I1 and I2. Okay, the directions we are assumed directions only. Okay, in this exam, they will not give to this this direction and this. Based on your assumptions only, you have to solve the problems. Okay, in external exam, they will not give the directions. I1 in this direction, I2 in this direction. Okay, you have to assume that first mesh 1, entering minus, that's why minus 12. Entering positive, plus 2 into I1. And then here, in loop 1, that's why I1 is current higher in magnitude. Then I1 minus I2 into 4. 4 into I1 minus I2 is equal to 0. Because of I1 is higher in magnitude in this loop. If it is, we are finding the equations in loop 2, I2 is higher in magnitude. Okay. Understood. And then mesh 2, 4 into I2 minus I1. Because of current, this branch, this element is interlinking with loop 1 and loop 2. That's why 4 into I2 minus I1. This resistor into I2 minus I1. This current in this direction, this current downward direction. That's why 4 into I2 minus I1. And then plus 2Vx. Entering positive. Now here entering negative. That's why minus 12. Entering positive. That's why minus plus 2Vx is equal to 0. And then Vx is equal to, what is the Vx here? I1 into 2 na. Branch current to loop current same here. This branch current, this loop current same, because of this branch is not interlinked with the loop 2. Understood? It's only in loop 1. That's why Vx is equal to I1. By solving this equation, substituting this equation, Vx is equal, here you will get I1, I2 and Vx is equal like this. That's clear? Understood? Use mesh analysis to find Ix in the circuit, Ix. Assign meshes first, I1, I2, I3. 3 meshes, na? 3 loops. This one loop and this one loop and this another loop. In mesh 1, first try to consider here mesh 1. Entering minus, na? That's why minus 2. Here plus 0.I1 is interlinking with only loop 1. That's why 0.1 into I1 is not connected between 2 loops or 3 loops. So only in one loop, separate. That's why 0.1 into I1. First, write all of you fast. Entering at minus terminal, the current entering at minus terminal, that's why we have to take minus 2 amps. Minus 2. Voltage, na? Minus 2. Here also we are finding the voltage drop. We have to find the voltage drop. 0.1 into I1 is called voltage. 0.1 into I1. And then coming to here, 0.5 is interlinking with I3 and I1. Linking, this is connected between two loops. Na? That's why we are in first loop. That's why. So what is the current direction? Current magnitude I1 is higher. That's why I1 minus I3 in this direction. I1 minus I3 is 0.5. Then coming to here, I1 is higher in magnitude. That's why I1 minus this opposite direction. I1 minus I2 into 0.1. I1 minus I2 into 0.1. That is the called mesh 1. And then mesh 2 in this mesh 2. Okay. Started 0.1 here. Try to start started at here. No? 0.1 into this current direction, upward direction. Okay. This current direction, upward direction. This current direction, downward direction. 0.1 into I2 minus I1. Understood? 0.1 into I2 minus I1. And then coming to here as interlinking with I3 and I2. That's why 0.5 into I2 minus I3 because of we are in a second loop. Okay, first try to considering an I2 only. First element is I2. That's it. Okay. Then coming to here 0.1 into I2 only. 0.1 into I2 because of it's not connected between these two. And then entering positive now. Plus 3 is equal to 0. That's it completed. And then third one here. There is no mesh equations, super mesh equations because of there is no source between two meshes. Single source is not connected. Na? Here I1 this is two meshes. There is no current source. Na? That's why there is no mesh equation, super mesh equation. And this also. There is no super mesh concept here. And mesh 3 so 0.5 into I3 minus I1 and it means I1 here start here onward start 0.5 into I3 minus I1. This current is in this direction and this current is opposite direction. That's why 0.5 into I3 minus I1. Then coming to here 0.2 into I3. Understood? Here plus 4 entering it plus 4 and then coming to here 0.5 into, so we are in mesh 3 now. That's why I3 minus I2 is equal to 0. By solving these three equations, we will get I1, I2, I3. And then what is the current Ix here? What is the current Ix here? Ix is in the direction. I1 is in this direction. Okay. And I2 is the opposite direction. What is the resultant current here? I1 minus I2 current is downward direction. Then that current is equal to Ix. It's clear. The current Ix is nothing but I1 minus I2. If I2 is higher in magnitude, I2 minus I1, that is equal to minus Ix, opposite. Okay, minus polarity if I2 is higher in magnitude. Here I2 is equal to minus 14.9 and then I1 is equal to minus 8.69. Then I1 minus I2 is equal to 6.29. That positive means downward direction. If it is a negative, okay, opposite direction, we'll get opposite direction. So this is the problem regarding